Hello. In this next video, I'm going to use GLADDvu to fit the same deer data set from T4 lysozyme, the same data set that I used in the DD video. The results will correspond to those in Figure 1 and also Tables 1 and 2 of our Journal of General Physiology paper. GLADDvu is available on GitHub. DD is designed to fit single data sets, and GLADDvu has been developed primarily to perform global analysis, that is, the simultaneous analysis of multiple data sets with different parameters linked or not linked. Here we're going to just be using GLADDvu to fit a single data set, and it will be illustrative of some of the basic procedures that you need to follow to fit data in general using GLADDvu. So I hope this video is helpful. All right, so what I'm going to do here is change to the directory where I've installed GLADDvu, and I'm going to run GLADDvu. I'm going to click on the Add File button, and that will allow me to select the T4L data set. And you can see there's a number of different panels that I can select here. There's a data panel. And this, in particular, if I select on the tab corresponding to my file name, you can see here's the full data set, the imaginary component before phasing and after phasing, and then here's a sub panel where I set the zero time. Now, as before, there's this glitch due to the fact that we're doing a Q-band deer data set. So I want to go ahead and truncate the last 500 nanoseconds of data. I'm going to select the process button. You can see now in darker green here is the data set that I'm actually going to be fitting. If I click on the answer panel button, you can see there's essentially what looks like an Excel file or an Excel table of all sorts of different values. Here are the initial values of various different parameters. There's a column that says fixed, which is if the parameter is going to be fixed during the fit, in other words, it won't vary, that the value in this column will be 1. Yes, it's fixed. If it's 0, it means it's not fixed. That value will float. Experiment and link are important if we're fitting multiple data sets, which we're not doing now. And then the lower limit and the upper limits are the lower limits and the upper limits that the value of the different parameters can take on. If I click on the Fit Panel view, you can see here, this will show me the data set, the initial fit, and the initial estimated background shown as a dashed line. And you get a slightly different view if I actually click on the dataset tab, the tab with the dataset file name, and in particular here the blue dots are the residuals of the fit minus the data. And I can get a view of the initial estimated distance distribution here if I click on the PR panel view. I'm going to go ahead and click on the Fit button. But before I do that, note that we're using a one component, it's a Gaussian, it's an exponential background, and we're going to use the interior point method for finding the chi-square minimum. So I'm going to go ahead and click on Fit. And that fit is finished. We have a one Gaussian fit to our data set. If I click on the PR tab, you can see that the one Gaussian distance distribution. If I click on the Answer tab and select the dataset file name, you can see the best fit values are here in the value column. All right, and here you can see the residuals of the fit minus the data set are actually already look quite good. I'm going to go ahead and try a two Gaussian fit. Oops, before I do that, I forgot to do something. I'm going to go ahead and go back to a one Gaussian, rerun that fit just to be sure, and then click on this one click button, which will allow me to save the results for one Gaussian fit in an Excel file. Okay, so now I'm going to, change the number of components to 2. There we go. Click on Fit and run that 2 Gaussian fit. And again, I'm going to click on this one click button, which will allow me to save the results for a 2 Gaussian fit in an Excel file. And I can go up here and click on the statistics panel view. And you'll see, like before, we got this little table of statistics for the different fits, n equals 1 or n equals 2 Gaussian. And as before, the BIC is lower for the 2 Gaussian fit versus the 1 Gaussian. Let's go ahead and try a 3 Gaussian fit. I'm going to click on the Fit button. I'm going to click on one click. I'm going to save those results in an Excel file. And you can see here the distance distribution. The scale on the distance distribution looks odd. The distance distribution is quite low. And that's because if I click on the data file name tab, you can see that there's actually this red shaded region is this very large uncertainty in what looks to be this very small, very narrow component. Like with DD, this 3 Gaussian fit is overfitting the data. You can see because it actually does, the 3 Gaussian fit has a higher BIC value. It has a lower reduced chi-squared value, but the BIC value is higher, suggesting that we're overfitting the data. If you look at the results here versus the results we got using DD, the BIC values should actually be quite similar. There's a slight difference in the reduced chi-squared values because actually the estimate of the noise value is slightly different using GLADDvu versus DD. And I can save these statistics if I click on this right statistics button. That will allow me to write the statistics table to a file, which I'll just call T4L.xlsx. Try that again, T4L. Here we go. All right, so that's fitting this T4 data set using GLADDvu. Let me go ahead and I think that's all I have to say about this. I hope this has been helpful. In the next video, we're going to be using GLADDvu to globally fit 3 data sets.